So you're saying, okay, so this is too high, and this is too low.
I think
Ideally, they would both be high, but if the training is way higher than the testing, then obviously.
Okay, so like what's like a good target? Like this is like 80%.
I think so. It probably depends on the forms.
People that are senior butt.
That's the time.
Yeah, I would say
It like what would be a good train test? That's what like should be like 50.
it probably depends on how much data you have. But
You're adding the moves stuff? Yeah. I thought that's like
I'm almost.
I'm not saying it was
I will
like
try it.
failure, I'm just saying it might be dangerous.
Okay.
I mean, I'd mind me more.
Thanks.
What was that?
Like 0.03%.
Well, he said, well, that's true. At this point, maybe we can go for it.
All right. Morning, everybody. Any questions on the homework? Yeah.
So on the, we're trying to improve the model, what sort of accuracy should we shoot for? Should we just
100%. I don't know. So what was your accuracy of the model I gave you?
about 38, 30, upper 30s?
Really? Is that?
I think it's higher than that.
The best time
Is
is
it low or high?
Okay, so like
No,
45.
is it low or high? What would you?
That sounds lower than I was expecting, but
I think it's 46.
Are you talking like training on one and then testing on another, or training on one and testing on the same farm?
Same farm.
Yeah, I'm getting
Cross
like
validation.
80% on test accuracy. After like, some methods.
Yeah, way better than mine.
so there's clearly a lot of variation. It's going to depend on the font and how you set up your training and testing.
What font do you use?
Yeah, the font.
I would say try maybe like 5 up to like 5 other models, and I would expect to see significant improvement. And that's what that means exactly is gonna depend on your accuracy of the original model. So if you're, getting 90% accuracy to begin with, right, a 0.5% increase is significant. But if you're, getting 40%, then 5 or 10% would be significant.
Yeah.
So things to play with would be adding more layers, changing the number of convolution filters, changing the kernel size, changing the max pooling size, the changing the dimension of the dense layers, that kind of stuff. Other questions? Okay. What do we find out about our favorite actors and movie stuff? So, which actor was in the most movies in that data set? So NA, there was a bunch of movies with no actors?
I took it out.
Yeah.
I took them out. Like 5.
Interesting. Movies with no actors?
Yeah, like NA.
Weird. So they had to field and they left it as empty.
Yeah.
Wow. Okay. What were some of those movies? Nature. Okay. Interesting.
Yeah, maybe animated or something. Voice actor.
I think the animated ones they list the voice actors usually, so that's surprising. Okay, besides NA, who else? Yeah, okay. Who I guess was like a real early. If you look at the movies he was in, it was like from like 20s and 30s, I guess. For those of you that found he was in the most movies, you used like the counter approach to loop through other movies. Those of you that just looked at the graph degree, what did you find? John Wayne has the highest degree in the graph. So any ideas why we'd be getting different results?
Wayne has more co-stars.
He has more co-stars, and what is that? How does that relate to higher degree?
He has more edges that are added every time we have a movie.
So we're adding an edge for each pair of actors in the movie. Right? So John Wayne's going to have more edges because he has more co-stars. If you look at the data set, it looks like there's the number of the actors are capped at 4, I think. So it's like the 4 biggest actors. And so I guess the Oliver Hardy is that the guy? He was like a real hotshot. He only acted with like 1 other person in most of his movies. And John Wayne usually had 3 other co-stars. So. How about Kevin Bacon? Is the 6 degrees of separation, is that true?
Not for
our data set.
Not for our data set. I got like 70% of actors have the connection. Well, have a connection within 6 degrees.
Yeah.
Yeah. So did anybody look at like a histogram of what the degrees look like? So
The vast majority of people didn't have a connection.
Yeah.
Within 6 degrees did not have a connection, period.
Yeah.
Didn't have it.
For a bunch of them.
So of the people that have a connection, mine kind of looked like this, where this was the 6 degrees. Yeah, I think this is 6 degrees here. It's actually, a good, I don't know, probably like 80% of the actors that are connected pretty quickly. So, and it's a little surprising to me that there's a bunch of actors in North American movies that aren't connected at all. But again, it could be issues with the data set or something else. What types of visualization did people do? Any? Okay. So drawing the whole data set is infeasible. Did anybody attempt to do that and have to restart their Jupyter kernel? It's too big to draw, right? There's no way you could get insight from looking at 40,000 or 50,000 actors with connections between them, right? So today we're going to look at how we might allow a user to visualize the data set, and kind of the trick is that we're going to add interaction. Okay? So the users can pick what aspect, what part of the data they're looking at. They can interact with it, and that's gonna make it possible to actually gain some insights. So we're gonna kind of start on that. It's not an easy task, so it's gonna take quite a fair bit of doing, and so we're gonna kind of build up to that. Okay. Before we do that, though, we're going to talk about the movies a little bit more. So the next task on the lab was to look at the Star Wars analog of the Kevin Bacon problem. And we want to know, are most movies within 6 degrees of separation from Star Wars? Is Star Wars is the movie version of Kevin Bacon?
So my question for that is, which Star Wars movies?
Oh,
A bunch of them?
I was just thinking a New Hope. I would just pick one.
And does that just mean any actor who has a connection to an actor who played it? So It was in Star Wars?
Yes, so we would have Star Wars, and here, fugitive. So this would be a piece of our graph, right? Star Wars and the fugitive are connected because Harrison Ford was in both. So, how are we going to create a graph like this? Yeah.
So you do like a two-step process. So you create all the movie nodes first,
Okay.
and then go back and you do like create like a dictionary of actors and their movies,
Mm-hmm.
and then or like an array actor versus array of movie, and then you can create the edges off of that.
Yeah, so we kind of need to know the opposite of what we did before, where we, for each movie, we knew all the actors in it. Now we have to know for each actor what are all the movies there. So we could use build that up using a dictionary and kind of just keep track of all those movies. So let's say I'm Harrison Ford and I have 100 movies. Say I have 20 movies that I've been in. What edges should be in the graph? Similar to something we looked at yesterday.
Like all the combinations of actors.
The combinations of movies. Right? So for each actor, right, for all of the movies that they've been in, right, we're going to take all of the combinations of two of them and add an edge to our graph. So we could, to get the list of movies that an actor has been in, we could build up a dictionary to do that. Another thing you could do is when you're building your original graph, you can attach extra information to nodes or edges. So when you're building the original one, for each edge, you can actually attach what movie the edge corresponds to. And then to get the number, to see the movies that an actor has been in, you can look at all of the edges connected to that actor's node and look at all the, get the movies from that list. So that's another way to do it. Yeah, our data set is not really actor centric, right? So this is kind of a little bit of a challenge to get the data that way. Okay. Cool. Any other questions about that? So let's keep working on that. We'll let's have that be due on next Tuesday. So that'll be the 23rd, and then the homework 6 is due next Friday. Is that right? Yeah. So I'll post that, but it'll be due on Tuesday. All right. So yeah, we really the only visualizations we've talked about so far are static visualizations where we have our information and we come up with some sort of picture. And I think now that we're seeing these big data sets, drawing a single picture to describe that whole data set is impossible. And so instead of drawing one picture, right, our approach is going to be to draw as many pictures as these once and give them the control to change what they see so that they can explore the data themselves and they can guide what is being drawn and how it's being drawn. So for this movie data set, like, what types of interaction do you think would be helpful for a user to in order to explore the data set? Right, so say you have this dump of data, you have a visualization developer on your payroll. What would you like them to create for you so that you can explore this data set?
Specify a target node and number of nodes.
Oh yeah, node selection. So this could be specifying particular nodes that you want to see directly. Say, okay, I want to see the node for Kevin Bacon and Harrison Ford. But it could also be like, I want to see the one ring neighborhood. So I want to see every node that is, a co-star of these people. So this being able to pick what you see is really important. What else would be helpful?
Like just show the connected nodes.
Um,
So give nodes in your graph that aren't connected.
I see. So restricting to a single connected component, or
Just kind of filtering out.
Yeah.
non-connected stuff.
so yeah, it's just generally like filtering is a big deal, especially when we have this kind of big data set. Yeah. What else? So our the layouts that we looked at for drawing these graphs were not that good, right? Especially as the graphs kind of got bigger. So what could we do to help the user with laying out like a node link diagram if they wanted to do that? Maybe the simplest thing is just let them move nodes. Right? So we want to give, we want to allow them to manipulate. And another aspect that might be important is the node link diagram is useful for some tasks, right? I can say, I kind of want to look in the neighborhood of an actor. I can see which actors are nearby, that kind of stuff. Pretty helpful for that. But there might be other views that that would be useful. So maybe I want to see a timeline view associated with the movies I'm looking at or something like that. So another thing that can be really useful is linked views. So this is another visualizing some other aspect of the data set, but it's kept in sync with the other stuff I'm looking at. So linked views. Okay. So this adds so much more power to our visualization because the user can choose, what they can explore themselves and figure out what's important to look at instead of us trying to come up with an algorithm to do that perfectly. Right? The user can use their intuition to do this stuff, right? So they can control both the layout and also which aspects of the data to look at. Okay, so that could be which views of the data are important, as well as which subsets of the data. Okay. So we're gonna, over the next week or two, we're gonna kind of build up a couple of simple graph visualization visualizations. So today we're going to kind of play with the movie data set a little bit. And we're going to use a pretty popular, although starting to get kind of old, library for doing this called D3, which is a JavaScript library for handling stuff like this. So D3 is very different philosophically from something like Matplotlib, which has a reasonably large number of pre-designed visualizations that are mostly static. D3 is basically, here is an API for interacting, for basically gluing data and DOM, like HTML DOM components together. And then you basically do everything. So you decide how you want things laid out, how they should be animated, how users should be able to interact with them, all that stuff. And so this is all, it's pretty manual. There's kind of libraries and plugins that can help with common behaviors and stuff that you might want. But it's pretty much like, so Matplotlib would be like a paint by numbers, and this would be like a blank canvas kind of thing. Okay. So that's what we're going to talk about today. Is working with D3, and we'll remember some JavaScript and all that stuff that we haven't worked with in a while. So the core idea behind D3 is that we have data and we have DOM elements, and somehow we want to connect these things together so that as my data changes, my DOM elements change to match. Okay. Or even if it doesn't change, like the DOM elements reflect what the data is. Okay. So if I wanted to draw a bar graph, right, my DOM elements would be rectangles, right, and their size or position should depend on the data. Okay. And so the key the key idea behind D3 is this thing called data joining. And basically the idea is I select a group of DOM elements and I say, here is the data that goes with them, and I can kind of conveniently update the attributes of my DOM elements based on the data. Okay. Maybe if I wanted to display like a list of data in kind of a crappy table, that would look something like this. So my data, I have some array of data that I'm interested in, okay? And I'd like to turn this array of data into HTML. Right? D3 can help me with that. Okay? So we'll just write out kind of the code to do something like that. So let's say I just want to, the way I've chosen to display my data is I'm just going to make a paragraph element for each one of these data points and just stick them directly in the body. Okay? So we'll look at more interesting ways of displaying data today, but for now, like, we're just going to do the dumbest, simplest thing. Okay. So basically, I want to somehow connect this array to DOM element, DOM paragraph elements. And so the way that I do that looks a little bit weird. So the first thing I'm going to do is I'm going to grab the parent. So this is like going to be the container that holds all this stuff. Okay. And then the next thing I'm going to do it's kind of weird. I'm going to select all of the elements that correspond with my data. Okay. Which seems kind of weird because at this point I actually haven't created any paragraph elements. Okay. So I said, I'm going to take my data and I'm going to put it, and I'm going to represent it by making a paragraph for each thing in my array. And so I'm going to select all those paragraphs, but I don't actually have any paragraphs yet. Okay, so kind of weird. This is like maybe optimistic selection. Okay. Okay. But that's the idea. So this is the DOM elements that I want to manipulate are the paragraphs that are in the body. Okay. Next thing I'm going to do, so once I have this, I'm going to say that I'm going to bind the data. So I'm going to say, okay, these paragraph elements correspond to this data array that I have. I'm going to name that my data just to make clear what the difference is. Okay. Right. So now I'm saying that there's this correspondence between the elements of this array and the paragraphs that are in my body. Okay. And now I can manipulate these paragraph elements using this data. And because D3 is interactive and my data can change, there's basically three possibilities of the relationship between my DOM elements and my data. Okay? So either the data that I have does not yet have a corresponding DOM element. Okay? So the first time I run this, right, there are no paragraphs. Right, so each of my data elements is associated with a paragraph that has not been created yet. Okay. The elements could already exist. Okay, so if I maybe added one new thing to my array, right, I would have one element that's brand new, and however many elements that already have a DOM element associated with them, already have a paragraph in this case. Or I could have an element that used to have a data associated with it, but that data is now gone. Okay, so if I deleted something from my array, I have a paragraph that used to be associated with an array element, but no longer is. Okay. And so the way D3 works is I basically specify what should happen for all of these, for each group of those elements. The new elements, which they call the entering set, the Excel elements that already exist that might need to be changed, that's the update set, and then the elements that are no longer have data associated with them, so this is the exit set. Okay? And so basically, so there's this function join, and in here I say, here's the function you should do for the new elements. Here's the function you should do to update existing elements. Here's the function you should do for elements that are going away. So we'll just do the simplest case here, where we're just going to add the new elements. Okay, so I'm going to have some function of the elements that I'm creating, the entering elements. And for each one of those elements, I have to actually create a paragraph for it, and then I want to set the text to be my data, for example. So here I would say enter. So for all these ones, I want to append a paragraph. This seems kind of weird. I selected the paragraphs, and then I have to append a paragraph, but that's the way the library works. Okay. And then once I've created this paragraph element, then maybe I want to set the text. But I need to do, I have to set the text differently for each paragraph. All right, I want each paragraph to have one of these values in it, and it should be a different value for each one. Right, so I can't just put like a single value in here and have that work, right? So any guesses what actually goes in there so that I can get a different different result for each paragraph? I can't put a value in there, right? What else could I pass? Variable. So again, there's not really a way to pass a variable, right? If I write out the variable, I get its current value.
Maybe pass another function.
So the trick is that I pass a function, and I'm going to evaluate this function for each data value, and so I can get different things out. Okay? So the function that I'm going to pass gets two parameters: the data, so that's the one of the values out of this array, which is going to be different for each one, okay? And an index. So the index is related to it's either related to this. There's like a few different ways of grouping. So I think it's related to the index of the array, but it might be related to the index of the selection. I can't remember. In any case, data is usually what we care about. Okay? And so in this case, the text I want is just the value in my array. So I just want to return my data. Okay, so the text for each one of my nodes is just going to be whatever data is associated with that paragraph. And so this is going to take my array of data, create a paragraph element for each one. Right? And I can do all sorts of other stuff here, so I can add styles, I could change positioning, I could do whatever I want. Anything I can manipulate with the DOM, right? So any attributes I want, I can manipulate through this, and it can depend on data. I can pass either a value, a constant value that I want to apply to all of these things, or I can pass a function to get a different result for each one. So that's kind of the basic idea. I have this data. I select the DOM elements that I want to be associated with that data. There's like one DOM element per piece of data. Even if these don't exist, I can still select them. Okay. And then if they're new, I run this enter function. So for the new ones, I'm gonna add something here. For the existing ones, I can do the same thing, but it operates on the existing set of things, and for the ones that are leaving, I can pass a function that. Usually, for the ones that are leaving, I want to remove them. So that's the basic idea. And so we're going to use this to create some like really custom visualizations. Okay. So this is again a really long way away from matplotlib, where we just say like plt.plot and we have a picture. Right here we're there's pieces that we can assemble built in D3, but it's like a pretty manual, custom kind of process. Okay. Right. So today we're going to get started on a visualization for the movie data using D3. So the skeleton HTML file is in the notes for today. So I encourage you to kind of play along. So this is what we're starting with. It is we're starting with just a HTML file, and it's basically I have just a div in the body, and I have a div and a SVG inside of it. Have we talked about SVGs before? I feel like maybe in the fall we touched on it a little bit. It's an image format, so it is an HTML-like image format. We can manipulate it with DOM stuff. So the elements that you would put in an SVG would be things like lines and circles and rectangles and text and all that sort of stuff. So that's where we're going to draw stuff. We could also consider using a canvas if we wanted to do that, but we're going to use SVG. This is what our little our app is going to look like. So over here, we're going to have, to start with, we're going to have the list of all the actors that are co-stars with Kevin Bacon, and then over here we'll have a representation of the graph eventually. So that's kind of the idea. So to start with, I guess other stuff in here. So I have all this style stuff I just put in HTML. It's just CSS stuff. Whenever I'm doing any sort of HTML stuff to start with, I pretty much always throw a border on my elements so I can see where they are, because I have never fully internalized all the CSS layout rules, so drawing boxes around stuff to figure out what's going on with them I find to be a really useful trick. Okay. And then here we're including the D3 library, and then our own code here. Okay. So let's go ahead and start with this. So the first thing we have to do is load our data. Okay. So we're going to do that with Ajax. I have created a shorter version of the IMDb file that only has the Kevin Bacon movies in it. I found that loading a 150 meg file over JSON every time I refresh the page was slowing down my development speed a little bit. So here we just have the 60 Kevin Bacon movies. So yeah, the first thing we're going to do is Ajax that file, parse it, and kind of load our our data like we did in our notebook. So the first thing we need to do is make an Ajax request. So everybody remembers, I believe that is, I believe that's Ajax. Good. So once I have this, I need to attach an event listener and then open it and then send it. So I need to, I'm going to have a function get called once my data is loaded. So maybe we'll call this load data. Okay. And then need to open it. So we're going to make a GET request, and then the file we want is just Kevin Bacon movies. And now we're ready to send it and actually make the request. And so usually the first thing I do, just make sure I got some data back. And so that's just in this case, it would be the response text of the JSON file. So let's see what mistakes I made. So here we go. Got our JavaScript console. And here we go. We got our JSON contents. This step specifically works much better with the 60 movie version rather than the 115,000 movie version. Right. So now we have our data, and we can start to process it and build our visualization. All right. So just like we did before, we want to parse each line in the file. There's a bunch of different ways to do it, but I'm going to use a for each loop. So the JavaScript there's like two different types of for each loop. There's a for of and a for in. And the for in, I guess, is used for objects. So it loops over the keys of a dictionary. And I think for arrays, it sort of works, but it goes in like an arbitrary order, is what I remember. So for looping through arrays, the for of loop is the way to go. So this is, we're going to split up our file line by line, and then we're just going to add it to an array of movies. So we're going to take our JSON line, we'll parse it. And then at the end, we should have our movies. Cool. So let's see if that worked. And it did not. We screwed up. Oh, we have an empty line at the end. So we're just going to skip over any empty lines. And then at the end, we get 60 movies. So, a lot of great ones in here. Another thing that maybe some of you noticed when you were playing with this data yesterday is that there's actually a lot of repeats in here. Not sure why, but it looks like Tremors is in here 3 times. So, if we were doing more serious analysis, we'd want to be sure to take care of that. But, not a great data set. Okay, so now we have our list of movies. Okay. All right. And we want to know the actors in our movies, right? So how can we get the actors, get all the actors in this collection of movies? Just loop through the movies. Right, how do we make sure we don't get duplicate actors? So I could like search through my list. That sounds like a quadratic kind of thing. Could use a set, and fortunately JavaScript has a set data structure, so we'll go ahead and use that. So we'll just make a set of all the actors and then go from there. And then for each movie, so we have an actors field in our JSON object. This isn't quite what we want. Right, because if we look at the actors, this is what we see. Right, so we have a string with a bunch of actors with commas. Not really what we want. And so how can we process this in a better way? We'll split it on comma space. And then we will add each one of these into our sets. And then at the end, we should have a nice set of all the actors. If I remember correctly, there's like 60 some or something. 137 actors. So we have all these actors. Great list here. All right. Cool. So, now we have our list of actors. Now we have data, and now we can start to do D3 stuff with our data. So the first thing I want to do is create a list of all the actors so that we can, like select from it, do all that sort of stuff. Okay. So I have another function that takes the actors. And I convert my set back to an array. Leave it. So I want to have things in order. It just makes things a little easier. Okay. So, let's think about where we want to put our actor list. So we have this div here where we can hold all the actors. That's the this black box over here. Okay. And kind of the easiest thing we can do is just make a paragraph for each one of our actors, and then it'll populate the list. Cool. So we could like loop through all the list and do some DOM operations and whatever, but we're going to use D3 to do it for us in like 3 lines. Okay? And it's so the first thing we have to do is grab the parent that we want to put stuff in. So we can use the D3 select. We can use like the CSS kind of selectors. So what do I want to select here? The actor div, and since it's got an ID on it, it's going to be hash actor div. Okay. And then now we get to the weird part, which is I'm going to select all of the paragraph elements in there, even though they don't exist. Okay. So that's kind of weird, but that's the way the library is designed. Okay. And then for each of those paragraph elements, I want each one of those associated with one of the actors in our list. So I'm going to say, hey, the data for that is my actors. Okay. And so now, with this join function, I say, okay, here's what to do for the new actors that you haven't seen before. Here's what to do for the actors that you have seen before, and here's what to do for the actors that were removed from the list. Okay. For this thing, we're only going to run it once. Right? So it's really just the entering set that's important. So we're not going to update or remove this because we're just making it once, but we're going to kind of go through the process. So basically, I need to write a function that takes a set of the elements and does something with it. A lot of this JavaScript stuff, so I could write that out, like this. So a function that takes all of the new nodes that I've just created. The shorthand that you see a lot are these arrow functions. So this is just shorthand for function of enter. you'll see this. Okay. And so what is it that we want to do for each one of these new paragraph elements that I'm creating? Well, first I want to make a paragraph element. So I'm going to append a paragraph element. Okay. Which again, seems weird. I've selected it and then I'm making it. It is weird, but that's perhaps the API names could have been selected a little bit differently, but whatever. Okay. So we just left it here, and we run this. What do we expect to happen? Should make like 100 and some empty paragraphs. So if we run it and look at the elements inside of our actor div, I indeed have a whole bunch of empty paragraphs. So that's kind of cool. We made paragraphs for everything. And so now we want to actually set the text appropriately. So like we had the example on the board over there. So we can set the text. But it needs to be different for each one of these, right? So we're going to use a function here. This like expression looks pretty funny, but this is shorthand for for these arrow functions, you don't have to write return out. So this is just saying the text in this should be whatever the data for this paragraph is. Okay, so in this case, it's going to be the name for the actor. All right, and there we go. Pretty cool. So yeah, all this is created, almost automatically by D3. So questions about what we've done so far? Okay, so we have our array of data. We use D3 to hook that array to paragraphs, and we're saying, hey, these paragraphs don't exist yet, so append them. Okay. So if we want to select actors, right? What do we need to do? Like, how would we go about selecting actors?
Would it be nice on the web screen when you select the
So I'm a user, right? I want to like interact. How would what would I do as a user to interact with these to like select them? Probably click, right? To do that, we're going to add event listeners for clicks. Okay. We can use D3 for that as well. So there's this function on. And so we're going to say we're going to handle the clicks when they get clicked. So this this looks kind of funny that start with lines with dot, but that's kind of the D3 style. So I'm continuing, like the white space, the new line is ignored. It's just I'm continuing what happened before. And it's especially confusing given that semicolons are optional. So like is this really the end of a statement or not? So I try to remember to put semicolons at the end. And then I'll like update. So I'll like, maybe I want to like change one more thing, and then I'll get a syntax error because I have the semicolon there. So just something to be kind of aware of when you're playing with this stuff. Okay. Yeah.
You scroll up just a second. What's eating
Maybe the same.
Yes, sorry. I should have mentioned that. So, to make an Ajax request, we're sending an HTTP request to a browser, to a server, right? And so if you just open the file from the file system, there is no web server. Sorry, I should have mentioned that. So there's this really handy, so there's a built-in Python library. And so there's, if you just run Python -m HTTP server, it just starts up a HTTP server in the folder that you run it in. And then these are all the requests that I've been making. So I've been getting, my HTML and JavaScript files over and over again. Yeah, Python -m means like run a module as main or something. And then http.server is like one of the standard library things. Sorry. So yeah, to do JSON stuff, or to do Ajax stuff, it's the way to go. So yeah, this is a pretty useful tool for all sorts of reasons. I don't know. Let's see. Can someone? I don't know if it's set up to block external connections or not. Does somebody mind trying to go to 10.17.254.171? And then should be colon 8000.
Yeah.
Hmm?
Directory list.
Okay. So I guess the moral there is be careful with this because it is public. I think for Jupyter Notebook, it has some sort of authentication or something so that I don't think you can connect to somebody else's Jupyter server without knowing like a secret code or something. But, this one is just public HTTP. Yeah, I can see people. Somebody just did a get on. Yeah, so yeah, it is public. So just be aware of that. Okay, so we got our actor list, and so now we're ready to deal with clicking. Okay. So one thing I want to do is mark the ones that are selected. So in my CSS, I have this selected class. So I'm just going to turn the background blue when I click on stuff. Okay. The first thing I want to do is basically toggle whether a class is selected or not. Okay. So we can use D3'd up with that. So the first thing is to get like the D3 wrapper around whatever element got clicked on. We can do that with D3 select this. So when this event handler is called, this is going to be the element it's clicked on, and then the D3 select gives me like the D3 wrapped version. So I can do D3 stuff with it. And then it's got this handy function called classed that will assign, will either, it takes the name of a class and then so if I do, I can say dot class selected, okay, and then it will add the selected class to my element. So let's go ahead and see what happens if we run this. And I hate to see that. Okay, so my clicker was working, but my class is not. So my click handler is happening. You see the index tells me where in the list it was that got clicked. Might be useful. Oh, sorry. Sorry. The class tells me whether or not the class is on there or not. Sorry. So to select it, I'm going to set this class to true. And so now as I click stuff, it turns blue because it has the selected class added. So that's cool, except that if I'm done with Demi Moore, I'm Ashton Kutcher, I don't want her selected anymore. Can't get away, right? So I actually don't want to set my class to be true. What do I want to set it to? The opposite of what it is, right? So I have to look up what it is and then do it, right? So again, instead of passing a value here, I'm going to pass a function. And the return value, what I'm going to get back is basically the opposite of whether it's selected now or not. Saying, hey, if it's currently selected, turn it off, otherwise turn it on. So this is like the toggle pattern. Right? So now if I run this, I can turn people on and off. Pretty cool, right? Okay. And again, D3, right? I applied this to everything at once. When I select these, really the reason I'm selecting them is so that I change what I'm drawing in my SVG, right? Yeah. So really, once I have these selected ones, once I change my selection, now I need to update my circles, right? So either I draw more or fewer circles based on which ones are selected. Cool. So we're gonna add one more function. We're gonna update our circles. So the first thing we're going to do is get is figure out which actors should be drawn. So I need data so that I can update these elements. So again, I can use the my D3 to get these nodes. So how do I know which which nodes are selected.
Just select.
It's a class, so it would be dot selected. And so this will give me back the nodes, the paragraphs. I don't really care about the paragraphs. What I care about is the data associated with those paragraphs. So I'm going to actually grab the data. So this is going to give me, so we'll just print this. This is basically the array of the actors that are selected. And so you see I have this list of actors that are selected. If I remove one, then my array gets smaller. Pretty cool. So the next thing we'll do is we'll just draw these as text over on the other side. Okay. We'll add more complicated drawing stuff probably tomorrow, yeah, for now we're just going to draw text randomly over here so that we can kind of just play around a little bit with SVG stuff. So what we want to do is we're going to add text elements to our SVG, and they're going to be linked with the data that we have here. So again, we're going to start by grabbing our SVG, so I call that my canvas. And then I'm going to add text elements to my canvas. So again, even though they don't exist yet, I'm going to select all text elements. And then I want to hook those text elements in my SVG to the actors that I have selected. So I'm going to hook that up to my selected actors. And then I'm going to say, okay, what should I do with this? So for the actors that are newly joined, right, I need to create a text element for them. And then I'm going to set the text. Again, since I want it to be different, I can't pass just a constant value here. I want to pass the name associated with the data. Right, so again, I'm going to use this silly looking function here. So this just says, give me back the value of my data, which in this case is going to be the actor's name. Right. And then I'm going to position it randomly in my image. So I'm just going to do a little bit of the width of my SVG canvas. It's kind of a pain to get this because the width that you get back has px attached to the end. It's a string with pixels, so I'm just going to get the number part. So I'm just going to do parse float. Okay. So grab the canvas object, get the width part of its style, and then do parse float. So that's going to give me back the numeric value of the width in pixels. And then I'm going to do the same thing for the height. And then to get my random position, I'm just going to set the x to be a random number times the width, and the y to be a random number times the height, and so we'll get something somewhere in there. So that is the HT, the SVG attribute transform is how you can position stuff. And it looks weird. I'll write it out. So translate, and then it takes the x and the y in parentheses. This is a really terrible API, I would say, because it's like a string that looks like a function call that's like a pain to manipulate, but whatever. So my x coordinate is going to be the math.random times the width, and my y is going to be math.random times the height. And so this should put it somewhere random in the window. Cool. And yeah, that should be all I need for now. Cool. So let's go ahead and give this a shot. So I click the names. Oops, it doesn't quite work. Anybody see what happened there?
Every time I push it, it'll add it.
But so who's it adding? Somebody see the pattern? So it's always adding the last one that's selected. Okay. And the reason is because it is confused about how the DOM elements, how the text elements corresponds to the data. So it knows it has an array of data, but it doesn't understand the ordering, how they match up, which in this case I don't understand because it's seems like it should be pretty obvious. But the way we can fix that is we can add a key function. So say basically we're giving each DOM element a unique identifier so that we can figure this out. And so the way that we do that is we just add a function here. And again, we're just going to say, hey, the key, the way that you can uniquely identify these things is with the actor's name that's associated with it. So again, it's not entirely obvious to me why this is necessary here, but this is just saying we need some extra information so that we can uniquely identify which data corresponds with which code. So, and with that, I think we fixed that. Yeah. So now I can select as necessary. And automatically, when things get unselected, right, my array got shorter. So this function gets called a bunch of times, right? Every time I click, this function gets called, right? So when we select all the text elements, after the first time, some of the text elements already exist, and I'm saying basically the ones that already exist, don't do anything with them, right? The new ones, we are going to create a text element for, and the default for the ones that no longer correspond with data is that they're removed. So that's pretty cool. All this happened pretty much for free. Let's add one more thing. So let's say for the ones that are so for the ones that were already there, we're going to change the fill. Okay. So So after the first time I add something, it's going to be black, and then it should turn to green when I change the selection. That's the hope. I did not test this on my own, so if it doesn't work, that's just the law of live demos. But yeah. So my updated ones. Yeah. So the newest one is black, and the other one's fade to green. So this can be a really useful tool for visualization because we can make the things that are added kind of pop. We can add some visual attention to them, right, and kind of fade out the things that have been there before. And so we can do that. So tomorrow we'll take a look at D3 makes it easy to add transitions to stuff too. So the things that are disappearing, you can have them like fade out over time instead of just disappearing. So we'll kind of go from here tomorrow. Yes, this is kind of starting with the basics of what we can do with D3, and we'll build from that going forward. So the concepts here I think are a little bit weird. It takes a little while to wrap your head around, like, what's up with this data and join? Why am I selecting things that don't exist? It's extremely powerful once you kind of get the hang for what's going on. Any questions about this stuff? All right, cool. So we'll keep building on this tomorrow. Remember, for Tuesday, have the lab due, and Friday will be the due date for the homework 6. The next week is going to be kind of weird. On Tuesday, we're going to have a guest lecturer, Suresh, and I can't pronounce his last name. He is a faculty member that has his recent research is related to fairness in algorithms, and he's going to talk about some of the pitfalls of using machine learning and how it can result in basically biased and sort of harmful results. So he's a board member of the ACLU of Utah, so he's pretty, say, aware of how these systems get used in the real world and what dangers are posed there, or what dangers come up. He's also like an insanely smart computer scientist, so he's got a really good perspective on this stuff. So they'll be on Tuesday. Wednesday is Pioneer Day, so no class Wednesday, and then Thursday we'll have our normal class. The week after that, we'll have one lecture of new material, a final review, and then Thursday, I believe, is our final exam. So coming up real fast. All right. So keep working on the movie stuff, and we'll continue this tomorrow.